Going over a clean, tune, and inspect. So when we do a maintenance or a checkup on an air conditioner, this chart helps us or our technicians stay focused and check what's important. The way we do it is we do the things in orange in the winter, and we do the things in blue in the summer. Therefore, if we're in a maintenance contract or agreement with somebody, we come twice a year, inside, outside. Then we check these things all year round, and efficiency year round. The way it would work is it kind of draws the technician to the right points. So in the winter, he addresses carbon monoxide. He would check the heat exchanger or the flue exhaust and make sure it was all venting out properly. If he had an unsafe or a crack, he would make a recommendation or mention that here. He would address water leaks, drain pan, make sure it wasn't rusted, tilted, being used for the secondary even. He'd make sure the drain lines were clear. He'd address the ductwork, make sure it's sealed, assembled properly, check airflow. He'd check the efficiency of the air conditioner and the heater. In the summer, he would check the compressor. Ideally, the most important things on an air conditioner are the compressor and the condenser. The rest of the items are almost like wear and tear. You know, they could all be replaced fairly easy. Nothing on there is too complicated, but if your condenser coil rusts out, that's it. So that's why we draw the main attention to that, and we want to focus, kind of address that. And then the compressor is very important too, as it's the most expensive item and what people really want to last. So we check the starting amps, we check the insulation on the windings, superheat, the charge, and any item over here we check too. Condenser motor, capacitors, blower motors in the winter, the filters, the evaporator coil. Is it dirty or is it rusty? So that's kind of how this chart works and how it keeps us technicians focused on the right thing. So up here doing a checkup on these systems for the summer, and it's our first time being here, so I wanted to check all the duct seals. So what I'm looking for up here is just want to make sure the air quality for these people is good and the duct's solid with no crushes and no kinks. I want to make sure all the silicone seals are like this, solid, which they are, which this is a good builder, so I knew they would be. But I want to check the plenum also. As we can see here, we got sealant everywhere, so that's good. But I'm going to recommend a little sealant here in this spot, because that's a duct leak right there, or an air leak. We'll check all the sides. Our secondary drain pan is completely dry. That's good. All the ducts look well intact and with no real kinks. Everything's strapped. Flue is safe and good. One thing we look at is the flue vent here. You want to make sure you have proper clearance from any wood or flammable material, and you want to make sure your system's level and the drain pan there. You know, looking at the drain pan here, you see all this dust, so that's a good sign and an indication that the primary's doing its job and collecting all the water. All the seals are good. As we were just up in the attic, we saw that drain pan was okay. Drain lines are clear. Ductwork is assembled properly. Sealed. Yes. Carbon monoxide. We're going to check that in the winter time, but I could see the flue was okay. So we didn't check the heat exchanger for cracks or carbon monoxide because we'll do that in the winter. But here we are outside at the air conditioner, so let's check the compressor or the condenser coil. We're going to go ahead and clean it up.
With this type of unit, what goes on is the rocks get caught up under the coil right here. It's very important to clean those rocks out because over time the vibration will cause the coil to vibrate on those rocks, creating leaks. If you keep the rocks out of this machine and keep it clean, this coil will last a long time.
Okay, so we're gonna check our compressor insulation, check the windings. Okay, we're going to go to common. And ground. Nice. This compressor's in great shape, over 1,000 ohms to ground. Wow. Alright, that winding's doing real well. The run winding's doing great too. This compressor's in great shape. Now let's test the condenser motor. All right, so this is good to go. Compressor checks out like that. Okay, so Windings are good on the compressor. Now we're going to check its starting amps. So the way we're going to do that is we had to have everything off for a while. And we're going to get ready to give it power. Watch our amp probe here. 49 on start, so a slight high starting amp on this compressor. Okay, so the starting amps were a little high. So to make sure that compressor doesn't take more damage, because high starting amps will take your compressor out prematurely if left untouched. When you have a compressor pulling high starting amps, you can either do nothing, or you can install a kickstart kit to prevent that high draw in the beginning. So a kickstart would make this system last longer. So we're going to check the amp draw on the condenser motor here. Condenser motor's pulling 1.19, 1.18. It's rated at 1.4. So our condenser motor's okay. The motor and compressor capacitor, we just replaced this. This one's brand new. So check. Contactor, it's good. We're gonna be in the attic checking those next time. Filters are clean. So, according to these pressures, my subcooling is low, and I can't seem to get it high enough. My superheat is low also. So if I add refrigerant, it's going to go lower. Not what I want. So this is telling me to take away refrigerant, while my low subcooling is telling me to add refrigerant. Now, that tells us that the problem is not refrigeration, or I should say it's not a charge issue, over or under. It's either airflow, which we're going to go ahead and cross out due to our history in this home and what we already know. And so what we're going to say is that the metering device is a little large. So those are the two things we can check and recommend to the homeowner. The problem is not that bad because we do have some superheat and we do have some subcooling, and it's not that hot outside today. So, but no matter how you shake it, too low, too high, I believe we have a bad or a metering device in the attic that's a little large. One size smaller piston might make all the difference. So, action required on that charge. The charge is not perfect. If this thing was to last, I would want to pump down the charge and clear everything. And while it's open, we would change the piston. I don't know what's in there, but we'd get rid of it and put it in the right size. And this condenser coil's in pretty good shape too. So now, that thing you saw us do when we took this apart was very important, very vital. These machines here will last forever if you keep these rocks out of the inside there. Because what these types of machines do is the rocks get in there, and then this vibration you can hear rubs on that rock and you get leaks. And that's where the condenser coil leaks come from, in these types of systems. Notorious for that. So anyway, that was a check and tune. and that's how we do it.
Why would you choose anyone else? Las Vegas Air Conditioning.